Hello, and so yeah, we're gonna do some review problem for AMC 10. So here's the first question. So in this question, we're gonna start with the fraction at the bottom first. So this is gonna be 10 over 3. And if I take the 1 and divide that by the fraction, we just take the reciprocal. So that will become just 3 plus 1 over 3 plus. So 1 over 10 over 3 will be just 3 over 10. And then we'll get this guy to be 1 over 33 over 10, which will give us 3 plus 10 over 3, 33, because we take the reciprocal again. And that will be just 99 plus 10 over 33, which is going to be 109 over 33, which is choice D. Again, this is the first problem, but sometimes we mess on the even first problem, so that was slightly easy. Okay, so let's do the next one. So the second question is the might cycle 15 laps in 57 seconds, 15 laps in 50 seconds, 57 minutes, and then assume he cycled at a constant speed, and approximately how many laps did he complete in first 27 minutes. So like, since we know, we can kind of do this a couple of ways, but one thing is like 27 minutes is what we are interested. I'm going to multiply this by unit fraction, so to cancel the minutes. So I will say this is going to be 57 minutes in the denominator, and then 15 laps in the numerator. So you don't need it, but I just did it this way. And then that's going to be canceling each other, so we can get the number of laps per answer. So 57 is divisible by 3, so which is 19 times, and that will be 5. And if I want to multiply 5 by 27, so 5 20 is 100, 5 7 is 35, which is 135 over 19, and that will be laps. So then, you know, if I take the 19 as 20, so 20 times 6 will be like 120, but that is 19, not 20, which is a bit smaller number, so we expect to get larger than 6. And also, we have 7 as option, so that should be our the best approximation. And if you kind of don't want to miss with the even second question, so you can easily just do the long division, which will give us 7 is the best approximation anyway. Okay, so that was the number 2. And the number 3, so the sum of the 3 numbers is given 96. The first number is 6 times the third number. So I'm going to say the third, let's say x. The first number will be 6x. And the third number is 40 less than the second number. So the second number should be like x plus 40. And then we are looking for the absolute difference between the first and the second one, which is the first is 6x and the second is x plus 40. So we will see which one is bigger. And the sum is 96. So you got 6x and x plus 40. When you add all of these, you got 96. So you will get 8x equals 56, and x is 7. Okay, so if x is 7, so that is 42, that is 7, and that is 47. And then we want to find the difference between the first and the second. So the first is like 42, and the second is 47. So if you take the absolute difference, we would just get 5, which is choice E. Okay, so far, they're not too challenging. The first problem, I feel like this is slightly challenging because of the wording. And in some countries, efficiency is measured in different ways, okay? In some countries, it's liter per 100 kilometers. And while the other countries is like uses miles per gallon. And we are given some ratio between the kilometers and in miles, and then 1 gallon is equal to L liters. Which of the following gives the efficiency in liters per 100 kilometers for a car that gets X miles per gallon? Okay, so this is kind of quite challenging, to be honest, especially because of the wording, and the numbers are not really given in a way that we like to. So the first thing I'm going to say, the efficiency is the term that we need to know. So efficiency, I'm going to define as going to be like efficiency is going to be like just the distance, which is like miles or kilometers, over the, I will say, gas consumption. So it might be like the gallon or the other one, so which is going to be liters. So I will say amount of gas, maybe. Oh, yes. So like, you know, when you look at the speed, we just say distance per miles or per gallon, whatever. I mean, the distance like in miles, let's say like miles per gallon is going to be our kind of a rate. But when we talk about efficiency, we just kind of flip that fraction basically. Okay. So then in our case, we wanna find the x miles per gallon. Okay, so let me write that x miles per gallon, which is 1 gallon. Okay. So this is what we are interested in, but we want to get in liters per 100 kilometers. So then I'm going to multiply this by a unit fraction. So when I say unit fraction, we just means 1. So, but we also know 1 kilometer is equal to m miles. Okay, and then 1 gallon is equal to L liters. Okay, so we want to find the miles, but we want to make that in gallon, like in liters. and kilometers, right? So what we have is like, we want to replace miles. So maybe we can divide this by m. So we can divide this by m, so to cancel those. So the miles is going to be 1 kilometers over m. So which means this could be written like, I can say this is going to be x times 1 over m kilometers. So that's because equals to miles. And a gallon is going to be 1 liter. So we can just replace with that. So that should be like, this is equal to 1 liter. Okay, so if I simplify this a bit, so you will get just going to be like m could be written in the denominator. So you will get x kilometers over m liters. Okay, but the thing is, we do have L as well. So we kind of had the L as well. So it says L liters. So this was actually L. So 1 gallon was L liters. So that should be L. So we have L times m liters because that has to be converted. But the thing is, we have some option that is kind of close to what we are looking for. We need to think about this as well. So it says in liters per 100 kilometers, which means we want the denominator, like we want the numerator to be 100 kilometers because it says per 100 kilometers in liters. So that means you want to actually move the x from numerator as well. So we can maybe divide by x top and bottom. So you will get, let's say, 1 kilometer over. So the L times m, I'll say liter over, because we divide by x, so that should be over x. But at the same time, we want to divide the top and bottom by 100 as well, so because it says per 100 kilometers. So you get 100 kilometer over L times m over x liters. So per 100 kilometers, we are going to use this much liters basically. Okay, so then if I want to simplify this a bit, so you should get the answer as L times like m. So we do multiply top and bottom 100. So I think I should have 100 right here as well. So the 100 times L times m over x liters per 100 kilometers, so which is choice C. So this was kind of challenging to be honest, but I hope that makes sense. So I'll see the next question. Okay, so we have a square ABCD, side length of 1, and PQR and S lies on side ABCD such that APQCRS is a large convex hexagon with side length of S. Okay, and then we want to find the S from here. Okay, so let's kind of visualize what's going on. So we have a square. Maybe I should start with that. Okay, so we have the, which is not a perfect square, but it's okay. And then we will connect the PQ, let me call this ABCD, ABCD. And then PQRS lie on the side ABCD. Okay, so we have 4 points basically. So let's say this is P and then Q. So we are going to take the midpoint so we can kind of get the somehow regular, even though it doesn't say that. But it says equal convex, so which is actually telling us the hint. So PQR, actually this is Q, this is R, and then this is, let's say, S. Okay, so then let's connect these. Okay, so it doesn't look like equal convex hexagon, but we do have the, actually, we don't have the hexagon at all. So we should have something. It says AP, right? So the AP, so we have the APQ and then CR and S. So you do get something like this. Okay, so I think that's reasonable right now. And then hexagon has side length of S. So which is also given, this is S, 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 and S right here. And we want that S. So, and also we know the side length of the square was 1, so which means this is 1 minus S, 1 minus S. So at this point, I think we can just use a Pythagorean or 45, 45, 90 triangle. So to get the relation between these sides, because this is 90 degrees, since we have two sides are 1 minus S. So in that, like PBQ, we can use the 45, 45. So which means 1 minus S times root 2 is equal to S. And if I want to get the S alone, so I can maybe expand first. So the root 2 minus S times root 2 equals S. And then root 2 will be S times root 2 plus S. So if I pull the S, you get root 2 plus 1 equals root 2. And then if I divide by the numbers in parentheses, you'll get root 2 over 1 plus root 2. I'm going to multiply this by 1 minus root 2, 1 minus root 2, so we can make that rational denominator. Okay, so then the numerator becomes root 2 minus 2, and the denominator will be 1 minus 2 because of difference of square. That's -1, so you got 2 minus root 2. So we got 2 minus root 2 for the S, which is what we are interested in. Okay, so that was, we'll say, slightly challenging for the number 5. But let's see the next one. So which expression is equal to this given absolute value? We can kind of plug numbers from the choice, which is okay probably. But let me remind something. Let's say we have x on their square root. Let's say this is the case. If this is like x squared, this is going to be x if x is positive number. And then if you have the same situation, that will be negative x if x is lesser than 0. Because since we don't want to get the result to be negative, so if the x is negative, so you will square to get positive. So you get the negative of negative will be positive, okay? But that's just definition. And then we are told A is lesser than 0. So then A minus 1 is also lesser than 0. So when that's the case, to make this A minus 1 positive, when you take it outside, you just pull A minus in front as well. So you get minus of minus A minus 1. So if you want to kind of consider that way, A minus 2. Okay, so then you get A minus 2, and then negative on negative will be positive, so you get A minus 1. So if I simplify, you got 2A minus 3. Okay, so we got that. So it looks like choice A is kind of reasonable, but we want to make sure we are kind of doing the same thing correctly. If A is lesser than 0, that means 2A is also lesser than 0. So the 2A minus 3 is lesser than negative 3, which is a negative number. So when you have a negative number in absolute value, you just negate the expression. So you got 2A minus 3 is going to be 3 minus 2A, which is choice A. Again, if you don't see this, you can just go ahead and plug numbers for A, like let's say negative 2 or negative 3, and just go ahead and plug those and choose option and see which ones are not correct. And then you can eliminate choice of what means as well. Okay, so here's the number 7. And the least common multiple of positive integer n and 18 is 180. And the largest common divisor of n and 45 is 15. So we have the GCD. Actually, no, not GCD. The least common multiple, LCM, of n and 18 is 180. And then GCD of n and 45 is 15. What is the sum of the digits of n? Okay, so like first things, let's try the like the prime factorization. 18 is like 3 squared times 2, and then 180 is just 10 times 18. 10 is 2 and 5. So you got 2 squared times 3 squared times 5 to the first, and then 45 would be just 3 squared times 5, and then 15 is 3 times 5. Okay, so that's so far so good. So what we know is the LCM, the least common multiple of two numbers, is 180. So to get 180, we need to get 2 2s, 3 2s, and 1 5 in at least one of the each numbers. So 18 has 3 squared, right? So that means, and then 2, but we need 2 squares, which means n has to have 2 squared and 5. Otherwise, we cannot have LCM to be 180, because LCM should have 2 squared, 3 squared, and 5 to the first power. But those factors should be coming from either n or 18, because we look at the largest power. That means n should be 2 squared times 5. Okay, and then if I kind of look at the GCD, which means n should have 3 and 5 as well, because the GCD has to have both factors in both numbers, right? So in that case, n should have 3 as well. Okay, so then I'll say n should have 3, because I didn't write 3 in my first selection when I take the LCM, but we should have 3 and 5 in n, because GCD is 15. So, but LCM does not require 3, but because 18 has 3 2s, I mean 2 3s anyway. So that's why I just didn't take any 3s in that case. But for the second case, we should have at least 1 3. Actually, we have at most 1 3, because n shouldn't have more than 1 3s anyway. Okay, so that means this is our n. So based on this, we are looking for the sum of the digit of n, right? So if I take the 2 and 5, that's 10. 2 and 3 is 6. That should be 60. And the sum of the digit is going to be 6. Okay, so that was a good one. And the next one is number 8. So the data set consists of 6 positive integers, and then we are given 5 of them. X is the next one. The average of those 6 numbers is equal to a value in the set. What is the sum of the possible values of the x value? Okay, so first thing, maybe we should try finding the number itself, right? So maybe we can just, the sum of those numbers first. So let's try that. So 1 plus 7 plus 5 plus 2 plus 5 plus x. And then we divide this by 6, and then we are going to get one of the numbers. Okay, so, but when you add the numbers, they get 7, 14, and then you got 6 more, that's 20. So 20 plus, I will say x over 6 should be one of the numbers. But when you divide by 6, you get one of these numbers. You can go ahead and check each one of the cases, which is probably not a bad idea. So we can try the, if I want to say like 1 for the result, because it has to be one of these numbers. 6 times 1 is 6, but 20 is already larger, and we want positive integers, so 1 does not work. If I want to go with 2, 2 times 6 is 12, that doesn't work because 20 is already larger. And then we have only 3 options, either 5 or 7 or the x. So if I say the result, let's say 20 plus x over 6 is equal to 5, or 20 plus x over 6 is equal to 7, or 20 plus x over 6 is equal to x. In the first case, you got x equals 10, and then you got 22, and then you got 5x equals 20, which is x is 4. And we are looking for some of all possible values. So we got 4, 26, plus 10 is 36, which is choice 2. Okay, so that was number 8. And the number 9 is a case or counting, I will say. The rectangular partition into 5 regions is given. Each region can be painted a solid color, so red, orange, yellow, blue, green. So we have 5 colors, so that each region touch or paint different colors. Colors can be used more than once. How many different coloring are possible? So there are a couple ways we can try probably. One thing is I can do casework. my first approach is maybe I can use all 5 colors. Okay, case 1, use 5 colors. And then if you use 5 colors, then there's 5 spots. So like I can choose one of those 5 places for my first color. Let's say here, the first one. So you got 4, 3, 2, and 1. So it doesn't matter what order you do, but let's say for red color, you can choose one of those 5 options. Okay, and then let's say for the orange, you have 4 options, and then yellow is 3, blue is 2, and green is 1. So you got 120 ways you can do this if you want to use all 5 colors. Okay, so that wasn't huge deal, but the second one is slightly interesting because let's see case 2. I'm going to use 4 colors. So if you want to use 4 colors, you kind of need to determine what colors you are using. So since we have 5 options, we just need to choose the colors first. So we can choose 4 ways to determine the colors. Okay, and then we just need to kind of like determine what rectangles are going to be those colors. Since we're going to use 4 colors, and then we cannot have 2 adjacent the same, so we can have, let's say, this one and this one would be one color, or this one and this might be another color, or maybe I can have, let's say Siri and see these 2 are the same color. So which means there are 3 ways actually I can determine what color will be used twice, because we can have 4 colors. So which is why we need to make sure one of the colors will be used twice. And then the color that we use twice, whatever color we decide, is not really doesn't really matter, but we kind of have 3 options for that color. So okay, so we got 4 colors, and then we need to determine how many ways we actually choose that color that will be used twice. That's 4 ways. So let's say I'm going to choose this guy and this guy. Maybe I should use the name of the color. Let's say this is red, and then this is red. So we already done 2 spots. And then we have 3 other colors are left, so we can just complete the rest 3 factorial ways. So that will be just 5 times 4 times 6, which will be actually multiply by 3 as well, because we said 3 times like 3 different ways we can determine those red colors, right? So times 3, so you got 360. Okay, so 120 from here, 360 from there. Okay, which means we already have over 360, so ABCs are not correct for sure. And I hope that makes sense, because I said I can choose like this one and this one, the color that I will be using twice, or this one could be that red once, or this one and this one could be that red once, or whatever color we are using twice. Okay, so that was the second case, right? So the third case is maybe 3 colors. Okay, so if I want to use 3 colors, I need to make sure that since we have 5 spots, then 2 colors will be used twice. And then we cannot use any colors 3 times, because there's no way to get 3 different. Maybe we can try, let's say, A here, and A here. But in that case, 2 A's are next to each other, so there's no way. So which is why we need to make sure 2 colors are be using twice. Okay, so then, but we want 3 colors. So let's say this is red, and then we are gonna say maybe this is also red. That's 1 color. Another one we should use is gonna be like another color, but we cannot use 3 different colors more, because we already have 1 color used. So that means we are gonna get red maybe here, and then maybe yellow right here, and then yellow right here. So in that case, the last color will be whatever color we are using. So that means the yellows could swap and red could swap. So whatever color you're choosing. But since we are going to choose the 3 colors first, so which is going to be 5 choose 3, which is 10. And then we just need to determine what color will be used once, right? So which we have 3 options. So we're going to choose one of these colors will be used only once. So which is going to be 3 ways we can determine that. And then we're going to just need to swap those reds or yellows. So that should be times 2. I believe that should be 10 times 6, which is 60. Okay, so that looks like these are all cases. So if I add them together, so you got 120, 360, and 60. So you got 480, 540. Okay, so we can do this slightly the shorter way of doing this one, but I kind of want to do the case for, so that was number 9. Okay, so let's do the number 10. So Daniel finds the rectangle index card and measures diagonal to its 8 centimeter, which is given, and then he cuts the equal squares side 1 centimeter at 2 opposite corners, and measure distance between those to close the vertices of the square to be 4√2. Okay, and what is the area of the original index? So we need the other, maybe the side of the rectangle, so we can kind of find that side, right? And then we'll get the other diagonal. So what we're gonna do, maybe we can just make a right triangle. So I will draw the horizontal and vertical legs, because we have hypotenuse, so we can just make the leg. But I don't know the other side, but I do know this is like 1 and 1. So which means this is also 1. If the other side was, let's say, x and typing, then you just drop 2 from that, so you got x minus 2. And the same thing going on here. So I will say y minus 2. So if I use the Pythagorean, so x minus 2 square plus y minus 2 square, is equal to 4 root 2 squared, which is 32. And if I use the Python in the larger one, so you got x squared plus y squared is equal to 8 squared, which is 64. Okay, so that is something. So like what we just need now, the area of the original one, which is x times y. But if I expand the first equation, so I will end up getting like x squared minus 4x plus 4 plus y squared minus 4y plus 4 equals 32. And I do know the sum of these two is 64, so I can replace that. And then you got negative 4x and negative 4y, so you got negative 4x plus y. And then plus 4 is 8, so you got 32. And I can subtract 32 from both sides, that's 32, plus 8 is 40. So you got 40 equals 4 times x plus y. And meaning that x plus y is just 10. Okay, so that is something, but that's not what we are looking for. We are looking for the area, which is given our x and y multiplied. So x times y is what we are looking for. But the good news is, we got the x squared plus y squared is 64. And then we know the x plus y equals 10. And then square of binomial will help us if I square this. So you got x squared plus 2xy plus y squared equals 100. And I do know this was given 64. So you got 64 plus 2xy equals 100. So the 2xy will be 36. So the xy will be 18. So we are looking for the area, which is xy. So that is 18. So I'll pause here. So I hope so far this question might be useful. So I'll see you in the next video.